So I'll explain you a bit out here, because it's quite noisy in there. But here on site we have two reactors, two fermenters. One is 200 liters in leg volume, and one is 2 cubic meters. Large scale, there are 50 cubic meters. And when we talk about this volume, it's only the leg of the U. So our fermentation technology is this U-loop. That has a U and a top tank. And in the first leg, you have a circulation pump setting. That one sets the pressure and circulates the liquid. On the top of the other leg, you have a back pressure valve. That one makes sure that there's high pressure in the leg and low pressure in the top tank. That's very important, because what our bacteria eats is methane gas, right? So, and if there's a physical law saying that the higher the pressure, the more gas you can push into your liquid. So there's a linear dependency between the pressure and how much gas is in the liquid phase. So the higher we can get, the more we can produce. So in the beginning of the leg, then the bacteria eats the methane and the oxygen, and then in the upward going leg, they produce the CO2, right? Basically. And then we of course want to degas the CO2 now. Otherwise we kill the process with too high CO2 concentrations. That's why we have the back pressure valve. Up there the pressure is reduced, and then the CO2 degases in the top tank. Then it all does the same again 1 minute after. So that's basically the process. There's 4 bacteria in there. There's 1 methane-eating bacteria. Then there's 2 cleaners, 2 cleaning ladies that make sure that if any cells die, the residual biomass is eaten, so we don't get infections by other organisms. And then there's 1 that eats acids. The methane we get into site is sometimes pure methane, sometimes it's natural gas. And natural gas is about 92% methane in Denmark. The rest is higher hydrocarbons, so that's propane, ethane, and so on. Our methane-eating organism cannot eat those substrates, but it can convert them into acids. So it converts them into propanoic acid, for example, and then this last bacteria eats the acids. So all 4 are important in our process. And it's quite rare that you have a fermentation with 4 different strains. Usually you do monoculture fermentation, so yeast or E. coli standard organisms, right? Good. Keep your glasses on. This is our supply room. So here we have different utilities. We have a steam generator standing in the corner. We have a spray dryer in there. That's what we use to dry the final product. We have compressors for air. The process air we use in there comes from there. We have 2 cooling stations with 2 different temperatures of cooling water. Over here we have our mixer tank. That's where we prepare the substrates, the fermentation use. And then we have 2 holding tanks for substrate for the fermentation. That's where the product comes out. That's the harvest tank where we harvest the product from the fermentation. And as I said, that's about 400 liters per hour with 2% biomass when the process runs well. And it does right now. Actually, the batch we are running in the big fermenter now passed 50 days a few days ago. So it's a long batch. That's basically it in here. Then let's go to the more interesting part. So this one is not, this room is not running at the moment. This is where we prepare the product. You actually hit us on a unfortunate day, because the last 8-9 weeks we've been running 4 or 5 days a week in here. But what happens here to our standard product, so what we do here is process development and product development, right? And the product development occurs in here. Our basic product we call uniprotein, which is a protein source for fish and pigs to begin with. is basically just removing water. So we centrifuge the product in our small centrifuge there. It takes about 500 liters per hour, and it upgrades the biomass from 2% to 15% dry matter. Then we run it into our homogenizer. That one breaks open the cells and release the protein into solution. It does that with pressure. So on the one side there's 800 bars of pressure. That's a lot. We have 1 bar here, right? 10 meters below the surface there's 2 bars. That one has 800 bars of pressure on the one side, and then on the other side there's 1 bar. And that huge pressure decrease destroys every cell. So 99.5% of the bacteria die in that step. And then we have a requirement to kill everything. We do that at the moment by heating. So that's basically just 120 degrees heater. The product runs to it, and then everything is killed. After that step, we spray dry the product, as I told you before. So that's our standard process. And you also see by the looks of the equipment that this is experimental equipment. That one we use for many different purposes. So we rebuild it every week almost to test out new processes. We also use that piece of equipment for Uniprotein Plus, which is actually our value waste product, what we produce in the value waste setting. That product, the idea of that product is that in our standard product you have about 70% of protein, 10% of ash, 10% of fatty acids, and 10% of nucleic acids. That's DNA and RNA. And that's just general terms, right? That's too high RNA and DNA content for humans to consume. So we need to decrease the nucleic acid content. And we do that by heating very specific temperature, very specific time, and doing some separations. So that's basically the Uniprotein process, that we concentrate the product and do a heating step, and then wash the process and concentrate it again. Then we have decreased the nucleic acid content from 10% to about 2%. And then it's all of a sudden fit for human consumption. There's of course a lot of trials that needs to be done before we can actually use it for that. But that's at least a good start. So we are planning the first application trials, so feeding it to rats by 1st of June. It started maybe today. Yeah. Yes. Value Waste also sponsored other types of equipment in here. Some of our separation equipment is sponsored by Value Waste, which we use to fractionate the product further. Yeah.
Can you just skip the step of the pressure and just heat it if it kills everything?
Good question. We're actually working on that. Some of the new products we have in pipeline, we've done exactly like that, because it might not be a necessary step. You're right. What we observe is basically that that one rips the cells open. When you heat, you collapse the cells. So you basically, like with a needle, puncture them, then they collapse. That means that some of the proteins is trapped in there. But we are not certain that actually makes a difference with regard to product quality. So might not be that important. Yeah. We also do some product development for fish trials. So we have an aqua product we feed to salmon. There's also some product preparation on that, where we work with optimizing it for fish, which is actually more, what do you call that, kræsne. they're more picky when it comes to their food. I didn't think that, but they are. It needs to have the right smell and the right taste for fish to eat it. Yeah. Yeah. No more questions. Okay. Then we roll back to Michael Jensen. Thank you.
Okay, thank you very much.
Yeah. We can leave the helmets in the fermentation tower. I'll just take them on the way.
Okay, welcome to the recycling plant. We'll have a walk. Yeah. And this is a recycling plant, but over there you have seen some pictures. That's where they reload the trucks to containers before they have the waste that collect with the citizens driven to Gemidan or other subcontractors. But let's go. Here, all cars are scanned, and if they have commercial cars with from the number plates, they will automatically get billed.
Is there a weight system for the trucks?
Yes, from the output. Yes, I don't know where they drive, but they weigh somewhere. If they do it here, or they have it over on the other. Over there, I think maybe they have. You can see the cars. I think they have a weight over there. So when they bring out the containers, they'll weigh them.
Yeah. Okay.
Up here, you drive with your car, or maybe you have a trailer on the car. And most Danish cars are prepared to drive with a trailer. And this is one of the reasons why, because most households come here once or more per month to deliver what they can't put in their bins at home. Here is insulation. Here we have PVC and hard plastic.
Jeg tror faktisk, vi skal på teamtur her om et par uger. Jeg tror faktisk, turen går herovre.
And old tires.
And all of this is reused.
Yeah, for
Yeah. For recycle.
something for reuse. Yes, that's bricks and yes. And you can see over there we have more, chemicals, and you put it over there and deliver it over there.
Lille bade med papir, det er så mange træer og sådan noget, ikke? Altså, så de sådan kan omsætte det til noget sjovt. Lige nu der er 2 dåser.
Not everything can be recycled. We have here asbestos, and that's not allowed to use anymore. So if you have a roof or something. Maybe you can see the cars. I think they have a weight over there. So when they bring out the containers, they'll weigh them.
Ahí en España hay algunos que merecen la pena, ¿eh? Vete al de San Javier.
Up here, you drive with your car, or maybe you have a trailer on the car. And most Danish cars are prepared to drive with a trailer. And this is one of the reasons why, because most households come here once or more per month to deliver what they can't put in their bins at home. Here is insulation. Here we have PVC and hard plastic.
Jeg tror faktisk, vi skal på teamtur her på ugen. Jeg tror faktisk, turen går herovre.
And old tires.
Ja, gerne.
And all of this is reused
They're for
or recycled.
something for reuse. Yes. That's bricks and yes.
Ja, der har de også en skoleprogram.
And you can see over there we have more, chemicals, and you put it over there and deliver it over there.
En lille balle med papir, det er så mange træer og sådan noget, ikke? Altså, så de sådan kan omsætte det til noget sjovt. Lige nu der er 2 dåser.
Not everything can be recycled. We have here asbestos, and that's not allowed to use anymore. So if you have a roof or something, you can put it here, and that will be on a controlled landfill.
Det var som en del af det. Det var ikke så
Oh, here you see garden deposits or garden waste, and this will be treated and made to compost. And I don't know how many times a year, but then the citizens can come and get some compost for their gardens. Oh, okay, in the corner there, then they can pick compost over here. They can do that all year. Okay, that is different from municipality too. But here they can pick up for their gardens. Here you can drop your garden waste, and when you have done that, you can pick it up, your garden waste from the last time here, and you bring it home to your roses. We have a lot of different fractions: gypsum, glass, paper, cardboard, soft plastic, and so on.
Thank you everyone for having taken part in the visit. Sorry for all the technical issues that we experienced, and thank you for your patience. Those were the sneak peeks that we were able to share, and I hope you enjoy them. We will be sharing in the coming weeks more information and edits that we hope are interesting for you. Thank you so much. We will be sharing more and better information about the project and the visit soon. Thank you so much. We will be ending this stream for now.